Aerosol light interaction is responsible for some of the most beautiful things we see. Richly colored sunsets and rainbow happen when aerosols interact with light, absorbing some and scattering the rest. Similarly, black smoke looks black because the aerosols absorb visible light. Our lab, Aerosol and Air Quality Research Laboratory, also works on developing new particle measuring instrument using this phenomena. In this example, a red laser is passed through a glass chamber and a jet of aerosols is introduced. Aerosols on the path scatter the light, making it visible. Scattering of light depends on aerosol size, wavelength of the light used, and refractive index of the particle. In layman term, composition of the particle. For aerosols smaller than wavelength of light, the light scattering is described by Rayleigh's theory. For aerosols way larger than the wavelength of light, the scattering is described by geometric optics. And for in-between sizes, the Me theory is applied, which has a great interest in aerosol science and technology. In this example, we demonstrate light scattering by 4 commonly used aerosols that differ in size and composition. It also demonstrates the 3 different scattering theories. While we see several optical events in the atmosphere due to aerosol light interaction, this principle finds its application in optical measurement methods with the advantage of being sensitive, nearly instantaneous, and not requiring physical contact with the particles. Several aerosol measuring instruments work based on light scattering principle. These instruments include condensation particle counters, aerosol optical spectrometers, particulate matter sensors, and nephelometer. With condensation particle counters, a stream of particles are drawn into an inlet. The particle size grows in a saturated environment due to the condensation of water or butanol vapors. When laser hits the particles, light is scattered and particles are counted, providing the overall concentration. When using an optical spectrometer, the sample air is led directly into the measuring cell via the aerosol inlet. The particles in the sample air are being detected by light scattering inside the measuring cell. The scattering light pulse of every single particle is counted, and the intensity of its scattering light signal is classified to a certain particle size. These instruments are used to measure aerosol properties in the atmosphere, understand aerosol exposure in indoor environments, perform global measurements of particulate matter using remote sensing, and several other applications. This important research continues to help us in developing advanced aerosol instruments for enhanced measurement of aerosols around us.